Hey guys, Mr. Martin with a video over inverse functions. So you should have learned in functions analytic geometry that a function is an inverse if you substitute it into another function and then you get x. And you should be able to flip this process where no matter which function goes into the other, you always end up with x. Two quick examples are if we have f of x equals x squared and g of x equals the square root of x. If we did the composite function f of g of x, we would get the square root of x squared, which is x. Or if we did the composite function g of f of x, that would equal the square root of x squared, which is also x. The other way is, say we had a function where we had f of x equals x minus 3 and another function that was g of x equals x plus 3. If we did f of g of x, that would be x plus 3 minus 3, which equals x. Or if we did g of f of x, that is x minus 3 plus 3, which is still x. The interesting property of inverse functions is, I'll let you read through this, but the chain in which the derivative, we end up with this property where the derivative of the inverse function is equal to 1 over f prime of, you substitute in the inverse function. Now in particular, we're going to be doing this with actual values instead of just functions. In the first example, we are attempting to calculate f inverse prime of 5. To do that, we need to know the derivative, evaluate what the derivative is evaluated at that point, and we need to know the actual inverse value for 5. So f inverse of 5 is easy to calculate. What input value gives us 5? In this case, that's clearly 3. So f inverse of 5 equals 3. Over here we would have 1 over f prime of f inverse of 5. So that is 1 over, we just established that f inverse of 5 is 3. So this is 1 over f prime of 3, which is 1 over 7 halves, which equals 2/7. So f inverse of 5, after a bit of work, we get to be 2/7. Moving to example 2, we don't have the information of knowing what like f of anything is. So to do this, we need two values. We need f inverse of 2, and we also need whatever the derivative is with that value substituted in. The first thing we need to do to find f inverse of 2 is set this function equal to 2. So we would have 2 equals x cubed plus 2x minus 1. If we set this equal to 0, we would get 0 equals x cubed plus 2x minus 3. Now if we have decent number sense, we'll see that if x is 1, then this is 0 because 1 plus 2 minus 3 equals 0, but some inverse functions are difficult to solve, so we'll use the calculator to verify this answer. If we type in x cubed plus 2x minus 3, press zoom, press 6, we can see that 1 is the value that produces 2. We can also calculate this. Remember, we did this in class. We will calculate the 0. We'll get really close. Press enter. we get x equals 1. So what we did again was set our function equal to the value for whom the input that we want to find, for which the input we want to find. So we get 2 equals x cubed plus 2x minus 1. We subtract 2, we get x cubed plus 2x minus 3. So this means that f inverse of 2 equals 1. Then what we're actually trying to calculate, if we go back to our original definition, we'll have f inverse prime of 2 equals 1 over f prime of f inverse of 2. Now, we also need the derivative. That would be f prime of x equals 3x squared plus 2. So we established that f inverse of 2 was 1, so we're looking at 1 over f prime of 1, and f prime of 1 is simple to calculate. That would give us 3 times 1 squared plus 2, which equals 5, so this equals 1/5. Moving to the next example, we have g of x equals the square root of x plus 1. We need to find g inverse prime of 2. Well, just like we did previously, we first need to find the input value that gives an output of 2. So we'll have 2 equals the square root of x plus 1. We should know that we square both sides. We end up with 4 equals x plus 1, and we subtract 1 from both sides, so we end up with 3 equals x. So our first thing that we know is g inverse of 2 is equal to 3. To complete our definition, we need the derivative, so g prime of x, so we can rewrite this to be x plus 1 to the 1/2 power. So its derivative is 1 over 2 times x plus 1 to the negative 1/2. And because of the chain rule, we multiply by 1, which quickly simplifies to be 1 over 2 square root x plus 1. So our calculation of g inverse prime of 2, that's going to equal 1 over g prime of g inverse of 2, which is 1 over g prime of, now g inverse of 2 we established to be 3, so this is g prime of 3, so our last calculation should be g prime of 3, which is 1 over 2 times the square root of 3 plus 1, which is 1 over 2 times 2, so 1/4. This equals 1 over 1/4, which equals 4. Last one is let f of x equal cosine x between 0 and pi. We need to find f inverse of square root 3 over 2. So we have square root 3 divided by 2 equals cosine x. If we remember the unit circle, I'm also at school recording the video, so hence the beep. Where is cosine equal to square root 3 over 2? That's in quadrant 1, so we should get pi over 6 equals x. So we get f inverse of, how do you write this? Square root 3 over 2 equals, what was that, pi over 6? So if we find the derivative, we get f prime of x equals negative sine x. And I guess we can go on and plug in pi over 6. So f prime of pi over 6 is negative sine pi over 6, which is negative 1/2. So when we're doing the calculation, f inverse prime of square root 3 over 2, we should get 1 over f prime of f inverse of square root 3 over 2, which is 1 over f prime of, this turned out to be pi over 6, and that value turned out to be -1/2, so we end up with -2 as our answer. Alright, so that's a quick video with inverse functions. Thank you for watching.